Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is minimum number of operations to make the array XOR equal to k. So we are given a zero indexed integer array nums, and then we are given integer k. We need to figure out like minimum number of operations required to make the bitwise XOR of all elements of the final array equal to k. That means we need to do the XOR of all the elements, and then we need to get the answer as k equal to 1. It can be anything. K can be from 1 to 10 power 6. It can be from 0 to 10 power 6. It can be in any one of the numbers. And then we need to make sure that after making the XOR of all the elements in the nums, we are going to get K as our XOR of all the elements. Now let us see what is a XOR. Suppose let's say I have given elements like in binary representation, which is like this, and then I'm given like 1 1, and then here there is one more 1, and then this is 0, and then the 0. So if we do bitwise XOR of all bit operations with the two numbers, then we are going to get like 0, and then for this it is going to be 1, and then for this it is 0, and then for this it is going to be 1, and then for this it is going to be 0. So whenever the bits are different, then we are going to assign it to 1, and then if the bits are same, then we are going to assign it to 0. So we are going to do the XOR of all the elements, and then after that we are going to get the numbers after making the XOR of all the elements, and then after doing that, choose any element of the array and flip a bit in its binary representation. And flipping a bit means changing a 0 to 1 or vice versa. Suppose let's say we take this particular example where we have 2, which is going to be 1 0, and then again 1, we are going to have 3, and then we are going to have 4. So this is going to be binary representation of all these elements, which is 2, 1, and then 3, and then 4. And then we need to make XOR of all these elements to be equal to 1. That means its binary representation is going to be 0 0 1. And then if we do the bitwise XOR of all these elements, then we are going to get here it is going to be 1 here, and then we are going to have 1 and then 1, which is going to be made to 0. So this will be equal to 0. Now we are going to get it as 0, and then again for this 1 and then 1 we are going to get as 0. So after this we'll compare this 1 0 0 with 1 0 1, and then let's say this one we need to get it as 0. That means we need to change one of this bit to 1, so that we'll get as 0. 1 XOR 1 is going to be 0. So we'll change any one of the elements which are present, and then we are going to change a bit in that particular element. For that, the minimum number of operations will be increased to 1. And then again this bit is going to become 0 after changing one of the elements with the bit of 1. And then again we are going to choose 0. 0 is same, so we'll not be changing the bit in any one of the elements. And then we are going to see 0 and then 1. So we need to get 1, but we do not have 1 as of now if we do the XOR of all these elements. That's why we are going to change this bit to 1, so that we'll get the answer as 1. So the number of operation is going to be 1 plus 1, which is going to be 2. So that's how we are going to calculate the number of operations which are required. So we are going to take XOR of all the elements, which is going to be 0, and then answer equal to 0. And then we are going to do the XOR of all the elements with XOR of all the elements with the num. And then we are going to take binary representation of XOR of all the elements with this particular bit. We are going to pick the ith bit which is present, and then we are going to pick the k. In k we are going to pick the ith bit, and if these two bits are not same, then we are going to use the operations. That's why we are going to increment the answer. At last we are going to return the answer. So for this, if we come to the time complexity, it is going to be big of n, and then the space complexity is going to be big of 1. Yeah, that's all for this video. Thanks for watching the video.